At 0247 hours local time, a Russian ammunition train carrying 64 freight wagons was rolling out of the Dzhankoy rail yard, heading south toward the front lines near Melitopol. The dispatcher believed the disguise was flawless. Every wagon had been repainted with grain cooperative markings and loaded with tarps stacked to look like sacks of wheat. But what the Russians did not know was that Ukrainian military intelligence had already mapped the entire line. Above the tracks, a Furia 2 reconnaissance drone was gliding in slow circles at 2,600 feet. Through its zoom camera, the operators spotted a half-collapsed rail bridge over the Chonhar Strait, a single surviving track forcing every train to slow to walking speed before crossing. It was almost the perfect choke point. Below, the disguised train kept rolling toward the bridge. What it was hauling was not grain at all, but 900 tons of artillery shells, rocket motors, and mortar rounds destined to resupply Russian batteries dug in across the Zaporizhia front. Everything seemed to be unfolding exactly as planned. But then, within just 4 minutes, the Ukrainian drone crew went from watchers to hunted. Every time the Furia 2 pushed its video feed back to the control van, it also leaked a faint radio signature into the air, and Russia's electronic reconnaissance grid had already begun listening. At first, the pulses were faint and scattered, but as the same frequency kept reappearing from the same patch of forest, Russian operators understood something was circling above their supply line. Meanwhile, the train continued crawling at 18 miles per hour, closing on the bridge. Just over 4 miles from the target, a Ukrainian strike detachment stood ready to send 38 first-person view drones into the fight. But between the launch site and the bridge, 3 separate rings of Russian defense were already waiting. The first layer was mobile electronic warfare vehicles stationed roughly a mile apart along the corridor, sniffing for any unusual burst of radio traffic. The second was a network of ground observers with binoculars and handheld direction finders, watching the tree line for anything that didn't belong. The third, and by far the most dangerous, was the Ptitsalov M, a next-generation counter-drone radar mounted on a rotating mast. It swept the tree line continuously, hunting for repeating emissions, and logged every burst from the Furia 2 as a fresh bearing line. One line meant nothing on its own. But as bearing after bearing accumulated and crossed at a single point in the forest, the picture sharpened fast. That crossing point was the Ukrainian control van. 90 seconds later, Russian self-propelled howitzers opened up. Shells tore into the tree line, throwing dirt and splintered branches over the crew's dugout. Only then did the operators realize their mistake. They had been transmitting continuously from the same clearing for nearly 6 minutes. On a modern battlefield soaked in sensors, that is the same as painting a target circle on your own position. Russian gunners have a blunt name for the tactic: hunting by signal. There is no need to actually see the target. Detect the emission, triangulate the source, and let the guns do the rest. For a few seconds after the shelling stopped, nobody in the dugout said a word. Dirt was still raining down through the branches overhead, and the antenna mast had been knocked half sideways by the blast. The team leader checked each soldier by hand rather than by radio, unwilling to risk even a whispered transmission, while Ptitsalov M was still actively hunting for a second confirmation. Only once the mast was reset and the gear checked for shrapnel damage did operations resume, this time under a strict new rule: no continuous feed, ever, from a fixed position again. After the first barrage, the crew understood they could no longer keep streaming continuous video. Every fresh transmission handed Ptitsalov M another bearing line to tighten its circle. So the Furia 2 switched into onboard autonomous tracking. Its processor picked out the shape of the train on its own, locked the profile, and kept following its movement without needing constant instructions from the ground. The electronic footprint dropped almost to nothing. Ptitsalov M lost the steady source it needed to keep closing in. But just as the crew thought they had slipped away from the counter-battery net, a second threat appeared. A Russian Orlan-12 reconnaissance drone was inbound from the northeast. Ptitsalov M had already marked the general area. Now the Orlan 12 was being sent to finish the job with a thermal sensor accurate enough to hand gunners a strike radius under 2 meters. The crew had two options: keep watching the train and risk exposure, or go dark and lose their live picture entirely. They chose to disappear. Transmitters were powered down, batteries wrapped in insulating blankets, and every soldier flattened beneath thermal netting. Within seconds, the dugout nearly vanished from any heat scan. But before going silent, they still had to pass the target data to the strike team, 4 miles away. Under normal procedure, the two teams would simply talk over the radio: coordinates, approach heading, timing. But that meant both units transmitting at once, doubling the signature for Petitsilov M to chase. That would be the same as drawing 2 targets on the enemy's map instead of 1. So the Furia 2's system used a sharper method. Its onboard computer compressed everything into a single burst: GPS position, train speed, wind data, and the recommended strike window. That packet fired out in one pulse on 868 megahertz. A banned Russian jamming cruise rarely prioritized for drone traffic, and vanished the instant it was sent. The strike team received the entire package at once. The whole transmission lasted just 0.4 seconds. Too short for Petitsilov M to fix a source, too tightly packed to decode on the fly, and on a frequency Russian listening posts barely watched. The strike detachment now had everything it needed. Ahead, the shattered bridge forced all 64 wagons into a single crawling line, grinding over patched rail joints and temporary steel plating at barely 9 miles per hour. At that speed, a section of the train carrying roughly 140 tons of ordnance was moving almost like it was standing still. If even one wagon detonated at the center of the span, the shock wave and flying debris could set off the wagons ahead and behind it, turning the whole bottleneck into a rolling chain of explosions. But Ukraine had only 7 minutes before the train cleared the bridge and picked up speed again. At exactly 03:01 hours, the strike team launched its first wave of FPV drones. Each airframe used a 9-inch composite frame, carried a 6.5-pound shaped charge, and had roughly 6 minutes of flight endurance. The target sat 5 minutes out. On paper, the math worked: 7 minutes of window against a 5-minute flight. But the Russians would never let a train this valuable cross undefended. The drones had to punch through 3 layers Russia had built around the bridge, and the first layer could bring them all down without firing a single round. Electronic warfare. Russian defenders had learned the same lesson everyone eventually learns in this war. You rarely need to physically destroy a drone. You just need to sever the link between the airframe and its pilot. No signal, no control. No control means the drone stalls, wanders off course, or tries to limp back to its launch point, and the strike collapses before it ever reaches the bridge. For the first mile and a half, everything went smoothly. The FPVs hugged the ground at roughly 5 feet, using drainage ditches, hedgerows, and collapsed outbuildings to mask their approach. The video feed carried a clean 1080p signal at 60 frames per second, sharp enough for pilots to pick out every fence post ahead. But the Russians weren't scanning visually. Riding with the convoy's escort was a mobile jamming platform, the Repellent 2, mounted on an armored truck. In practice, it worked like a radio tower built to do the opposite of communication. Instead of connecting signals, it flooded the whole corridor with electronic noise. Once switched on, Repellent 2 pumped interference across GPS bands, GSM frequencies, and the standard FPV control channels. Picture a pilot trying to whisper commands through a tin can while a foghorn screams beside his ear. The signal was technically still there. Nobody could hear it clearly anymore. On the pilot's screens, the picture began to tear. Static lines sliced across the frame. Frame rate dropped from 60 to 30, then collapsed to just 12, the kind of blurred, jittery image you'd expect from a decade-old webcam. But these airframes didn't sit on one channel. Their software-defined radios immediately began hopping across 96 separate frequencies, drifting into non-standard bands the Repellent 2 hadn't been tuned to prioritize. Part of the feed limped back, grainy and delayed but usable, letting pilots keep flying as the formation pushed deeper into the jamming envelope, less than a mile from the bridge. Repellent 2 cranked its output higher. The image froze, dissolved into blocks of static, and finally went black entirely. In older generation drone warfare, that would have ended the mission on the spot. But these airframes carried a second layer of guidance. The instant the link died, the onboard vision processor kicked in automatically. It began scanning raw camera frames for the geometry of freight wagons, the outline of the bridge deck, and the compressed line of rolling stock ahead. Once the pattern locked clearly enough, the system marked the target, a wagon near the center of the span, and steered toward it without waiting for any further input. Repellent 2 could blind the pilot, but it couldn't undo a decision the machine had already made for itself. From that point on, the humans weren't flying the attack anymore. The drones were finishing it on their own. There was no picture left, only telemetry. Altitude 5 feet, speed 24 miles per hour, heading locked steady toward the bridge. The camera link hadn't died completely under Repellent 2's pressure. It kept flickering back for a frame or two before sinking into static again. Those flashes were what saved the mission. In one frame, a pilot caught a glimpse of a distance marker beside the tracks. From its position, he calculated the bridge was roughly 1.3 miles out, and the train's last confirmed position was about a mile ahead. Heading was corrected by compass alone. The swarm pushed forward, now roughly 450 yards from the range where onboard vision could reliably lock the train. There was still no clear image, no way to confirm the exact span position. The lead pilot made the call to push the whole formation another 450 yards through the worst of the jamming. 6 seconds later, the feed snapped back. The swarm had cleared the densest interference zone, though the formation had drifted right of its intended line. The bridge appeared at the edge of the frame, while the ammunition train was still grinding across the damaged deck. Onboard systems began locking the target. But in that same instant, Russian interceptor drones dropped in from above the tree line at roughly 80 feet. They dove at a steep 55-degree angle, unarmed and stripped of any payload, so they could maneuver freely. Their only job was to collide hard enough to set off the 6.5-pound charge riding on the enemy airframe. The Ukrainian FPVs, weighed down by their warheads, had already burned nearly 4 minutes of flight. Batteries were sagging, and motors were working harder just to hold 5 feet of altitude. They could still push forward at 70 miles per hour, but sharp evasive turns were no longer an option. The unarmed Russian interceptors, lighter and faster, converted their altitude straight into speed, 2 of them accelerating to 115 miles per hour. Closing speed between the formations topped 185 miles per hour, better than 270 feet per second. At 450 yards out, the strike team had barely 5 seconds to react. Pilots tried to split the formation left and right, but the loaded drones responded sluggishly, inertia dragging them forward faster than the motors could compensate. At roughly 90 yards, impact was under a second away. 2 Russian interceptors slammed head-on into the 2 lead FPVs. The first collision triggered the shaped charge instantly, a fireball at 18 feet, scattering carbon fragments across the field. But that exchange revealed the pattern in the Russian tactic. Once an interceptor committed to its dive, there was no aborting. It either connected or plowed into the ground. For a moment, the strike team debated aborting the run entirely. 2 drones down out of the first pair meant a third of the lead wave was already gone before the swarm had even reached visual range of the bridge, and the remaining airframes still had to survive 2 more waves of interceptors before they could even begin their attack run. But pulling back now meant the train would clear the bridge untouched and vanish into open track, where no choke point would ever offer this kind of opportunity again. The order came back simple: continue. The Ukrainian pilots realized the loaded warhead wasn't only a liability, it could also be used to drop out of a collision path fast. A second wave of interceptors appeared at 380 yards, diving and accelerating toward the next pair of FPVs. At 220 yards, the pilots didn't dodge sideways. They waited. The gap closed to 140 yards, barely a second from impact, and at the last instant, the pilots cut power completely. Lift vanished. Under the warhead's weight, the drones dropped nearly 14 feet in under a second, falling straight out of the collision line. The Russian interceptors tore through empty air where their targets had been a heartbeat earlier, and at more than 100 miles per hour and only 20 feet off the ground, they had no room left to pull up. One buried itself in a ditch embankment, the other cratered into a field and went still. But the sudden power cut left the Ukrainian drones in a dangerous freefall of their own, no longer flying machines, just falling weight. Throttle back too hard and the drone could flip. React a second too late, and it would slam into the dirt. The crews had drilled the maneuver dozens of times on the range. Power came back gradually, just enough for the rotors to bite the air again, and the drones leveled out shaking at 7 feet. A third wave of interceptors climbed above the tree line, preparing another dive. This time, the pilots chose to set the trap themselves. The swarm split into two groups. The first surged to 115 miles per hour, charging the train as if beginning the final run, and dragged the entire interceptor wave into pursuit. Meanwhile, the second group dropped to just 3 feet, crawling forward like drones with dying batteries and no fight left. The Russians took the bait completely, chasing the faster group toward the bridge. Stretching the gap cost the lead drones nearly all their remaining charge, enough for maybe 40 more seconds of flight, with no intention of ever reaching the target. After 25 seconds of pursuit, once the interceptors were fully committed and clear of the bridge, the lead group cut hard into a 180-degree turn and drove straight back the way they came. Closing speed hit 250 miles per hour. The Russian interceptors had barely 2 seconds to realize their prey had become suicide drones. The collisions came in a rapid string, fireballs lighting the dusk as the shaped charges detonated, and within seconds, both formations were gone from the sky. From the ground, Russian air defense crews assumed the intercept was finished. They had missed the second group entirely. The drones written off as dead batteries were still creeping along the embankment at 3 feet, managing barely 22 miles per hour, but staying hidden behind the slope and scrubbed the whole way. The dogfight had lasted just under 40 seconds, but surviving it had drained the second group down to 7% battery. Meanwhile, nearly 3/5 of the train had already crossed the bridge, wagons still crawling nose to tail over the patched rail bed. Time was almost gone. As the range closed to 400 yards, the surviving drones broke cover, climbed to 35 feet, and pushed into their final run at 115 miles per hour, motors at full output, converting the last of their charge straight into speed. At this battery level, there was no margin for a sharp turn or a climb. One aggressive maneuver could drop voltage below the point where the motors could keep spinning. The Russians were ready for exactly that. Escort troops raised Volna P electromagnetic rifles from their firing positions, aiming directional jamming beams straight at the incoming drones, trying to sever control links and scramble onboard navigation. In theory, the Volna P reaches out to 4 miles. In practice, it only works when a soldier can actually see the target, keep the antenna locked on, and hold the beam steady long enough to matter. The lead drone was caught first. Its screen froze, control data dropped out, and it banked hard before crashing into the gravel beside the tracks. But the drones behind it didn't stop. The instant they lost their link, onboard vision kicked back in automatically, scanning for the outline of the bridge, the shape of the wagons, and the heat bloom of the locomotive still under load. Once locked, the electromagnetic rifles could still blind the operators on the ground, but they could no longer talk the drones out of a decision already made on board. Russian troops fell back on the oldest defense there is, small arms. Soldiers along the escort cars raised their rifles and fired steady bursts into the drone's flight path, not aiming to hit any single airframe, but to fill the air ahead of the formation with lead. At the rear, others carried shotguns loaded with buckshot, far more effective against fast, small targets that only stayed in view for a couple of seconds. At 140 yards, the first volley tore through the formation. 3 rounds connected. One clipped a propeller blade, throwing the drone off balance as its flight controller scrambled to compensate with the other motors. A second round punched through a carbon frame without breaking it apart, sending that airframe into a violent shudder. The third was the worst hit. It pierced a battery pack directly, and voltage sagged from 14.2 to 12.8 volts in under 2 seconds. Damaged cells couldn't keep feeding the motors at full draw. The picture dimmed, propeller speed sagged, and altitude started bleeding away foot by foot. Only 3 drones were left with any real chance of finishing the strike. Russian gunners kept firing, but the very hits that had damaged the airframes were now making them harder to track. One banking uncontrollably left, one bobbing up and down erratically, the last shaking hard on a punctured battery. None of them held a line steady enough for the shooters to lead properly. Inside each drone, onboard logic kept redistributing thrust across whatever motors still worked, fighting to hold altitude as voltage kept falling. The gap closed to 90 yards. Battery charge sat at 7%. Onboard systems dumped every remaining volt into one final burst of speed, the 3 drones surging forward at roughly 170 feet per second. Even as thrust began collapsing below the operating threshold, momentum alone carried them the rest of the way. In under half a second, they crossed the last 90 yards, skimmed low over the heads of the Russian riflemen, and dropped toward the ordnance wagons below. The shooters stopped firing outright. A stray round near an ammunition car was its own kind of disaster, and scattered for cover instead. At exactly 03:08 hours, the first drone struck a wagon near the center of the span. Its shaped charge detonated on contact, the jet punching straight through the steel hull and igniting the packed shells inside almost instantly. A blast wave rolled across the bridge deck, and within half a second, a secondary detonation ripped through the neighboring wagons as their own ordnance cooked off. Flame shot upward past 90 feet, dragging a column of black smoke several hundred feet into the sky. The pressure wave shattered windows on the escort cars and cracked already weakened rail ties along the span. The struck wagon buckled sideways, wedging against the bridge railing and sealing the crossing completely. Before the first blast had even finished rolling outward, the second drone arrived, dropping into the tight cluster of wagons, still bunched on the narrow span. Its charge detonated near the coupling of 2 adjacent cars, tearing one open and spraying burning propellant onto the next. Fire ran down the line within seconds. Trapped wagons had nowhere left to go. No room to reverse, no room to uncouple. Ammunition began cooking off car by car, each rupture throwing a fresh column of flame nearly 50 feet into the air. Cars at the rear tried to reverse away from the heat, colliding with each other as crews scrambled clear of the tracks. The third drone was still airborne, its battery nearly spent, but onboard vision kept the target framed. On the far side of the bridge, wagons that had already crossed hadn't yet picked up speed and were still bunched tightly together. The drone dropped its nose. At 45 yards, the last motor finally died, but momentum carried it home. It struck a wagon in the middle of that cluster, the charge punching through and igniting a fresh chain of detonations that ripped through the closely packed cars. Metal plating was thrown dozens of yards. Fire spread down the line, catching everything that hadn't managed to pull clear in time. Only the lead wagons and locomotive, already past the wreck zone, had any chance, the engineer pushing the throttle to maximum and hauling what he could away from the inferno. In under 12 seconds, 3 drones running on fumes had struck the 3 points that mattered most: the center of the bridge, the entry cluster, and the exit cluster on the far side. The train was severed in 3 places at once. What escaped up front had to keep running. What sat behind could go nowhere, and everything still trapped on the span was pulled into a chain of secondary detonations that would keep burning for hours. The real cost was never just the wagons lost. When a single rail artery like this goes down, the entire resupply chain behind it slows to a crawl. Shells, rocket motors, and mortar rounds meant for batteries dug in near Melitopol and Tokmak simply don't arrive on schedule. An artillery force running low on ammunition loses its ability to sustain fire, and guns that can't shoot become nothing more than expensive, stationary targets. Around Crimea and the southern front, scarce ordnance forces Russian commanders to ration shells between sectors, prioritizing frontline batteries over rear area training and reserve stockpiles. Within hours, satellite imagery would show the Chonhar span reduced to a twisted, blackened skeleton, the surviving approach track scorched for nearly 200 yards in either direction. Repair crews would need weeks, not days, to restore even single-track capacity, and every ton of ordnance that would have crossed that bridge now had to be rerouted through already congested lines further east, adding hours or days to a resupply schedule the frontline batteries were counting on. Strategically, this is exactly the pressure Kyiv is applying. There is no need for a frontal assault on a heavily defended rail hub. Instead, Ukraine picks apart the bridges, junctions, and depots one at a time, slowly turning a supply network built for a large-scale war into a fragile, patched-together system running on borrowed time. That's the core of asymmetric warfare here, a handful of drones costing a few $1,000s each, taking out a shipment of ordnance worth many times more, along with the rail infrastructure it depended on. It's a trade the defender can rarely sustain indefinitely. Every bridge, junction, or depot that goes down forces a choice between spending scarce engineering resources on repairs or accepting a slower, longer, more exposed supply route for months at a stretch. The 3 drones that finished this strike never had enough charge left to fly home, but they had exactly enough to sever a bridge, split a train, and force an entire logistics chain to pay for it. So what actually decided this fight? The autonomous targeting that kept flying blind through the jamming, the fake retreat trap that lured the interceptors away, or the choice to hit that exact bridge in the first place? Drop your take in the comments.